Hello everyone, and welcome to the stream. It's pretty spontaneous, pretty random, I'd say, but today I am going to do some casual coding, I'd say. Does it work? Yes, it works. Alright. We will be doing some casual coding in Rust. We will be making something really cool that will end up being a video very soon next year. It will already be a proper video next year. So we will be coding out of all things, a blackjack simulator. So I know this is quite a detour from Memflow and stuff, but it is what it is. That's why I'm not posting it on the Discord of Memflow, because it's not Memflow. But it will be using Rust. We will be creating a blackjack sim. And yeah. That's the thing. We'll currently work on a blackjack simulator. Next up, in other streams, I will expand on it because it is a really cool concept idea which I came up with, and it might work. It probably won't, but if it works, it's going to be really insane, and it will make a really good video, I think. So I just go to the main function, and I have absolutely no clue how should I be coding it, but let's think. Let's start with, I guess, a deck which has cards and which we will be able to shuffle and deal out, I suppose. So we will have a deck. What's up, JN? Is that how I'm supposed to be pronouncing it? Very good to see you in the stream here. I'm very glad for this. A deck will have a card. Oh shit! Thank you for telling me. Alright, I switched. Now, here we go. Now, we should be here in a Rust project. It's very simple. So far, I created just a bare Rust project, and I created a deck Rust file and a card Rust file. Card, I guess, will only have value and stuff. I'm not sure. Maybe card will be an enum, because so number, it will be a number value. I guess it's an I32. How's Rust compared to something like C++? Alright. So imagine you can write with C++ and C, you can write really fast code. It's a given, everyone knows that. But another thing that is very known about C++ and C is that it's very error prone. Now imagine you could write very fast code, and by default it will have absolutely no buffer overflows, absolutely no use after freeze, absolutely no issues regarding memory management and stuff, and that's basically Rust. It's C-like performance with, I don't know, something really cool like safety. And I mean, there are languages like Java and stuff which have, oh, you did a null pointer thing, or oh, this is a buffer overflow and stuff like that. Especially when it comes to like multi-threading issues, not many languages are good at it, at figuring out how multi-threading gets all mixed up. Rust has really, really rather strict, some say too strict rules about using multiple variables from multiple places, and it prevents you from making various mistakes of multi-threading by default. And like some people say it's very tough to write code because you can't just throw variables and use them everywhere. There are like strict rules regarding that. But I'd say most of the times it's just architecture being wrong. There are certain edge cases where it's not the case, but most of the times Rust just makes it really hard to write bad code that messes up in some really odd way which you can't foresee. So that's why I really like Rust. I don't know if it's a comma or a semicolon, probably a comma, and it's really nice. I'd say that's how they compare. The syntax wise, they're rather different, yes, but functionality wise, it's really nice. You've got a jack, you've got a queen, and you've got a king, right? And you've also got a ace. And deck is going to just have a cards. I'm going to use card. And this is gonna implement a modules mod deck and card. And I think something like this will work. Probably not, but then again. Are people in enterprise starting to pivot from C to Rust? I'd say yes. Like most of you see every day, like there is like Amazon starting to hire Rust programmers. There's Apple which say all new kernel code should be written in Rust. There's like the Linux kernel is adding Rust support. So it's slow because it's still like a rather new language. It evolves rather quickly. And I'm also not in enterprise, so I don't know how exactly it is, but from like just being in the community, you kind of get a sense that it is going that way indeed. So it's really cool in my opinion. All right, so we have cards. See you in a bit. I guess let's implement what's the value of the card. So value, it takes a self, and it's also gonna take a previous value, because you'll see an ace is either 1 or 11 in Blackjack, so you kind of need to know the value of the previous sum to know whether it's a 1 or 11, I'd say. I think it's really tough though. It's really tough though, because you could sum it up and then it becomes and then it goes down to like, hey, you could have you could have a, well, you could have a list of cards equals, you have a jack, well, jack number 8, and you have ace. I mean, technically you could have many aces, and at this point, wait, no, it doesn't really matter, does it? I'm just thinking how to best implement this value thing, because an ace, well, let's just do it naively for now. Let's use a U size here. Basically, in here, we return a U size. Hi, Delusion, good to see you back. We match a self. And basically, a number, U size, is going to be previous value plus, value. Then you have jack or queen or king is going to be previous value plus 10, right? And ace is going to be if previous value is less or equal 11, it's going to be 10. Up previous value plus 10, else previous value plus 1. And it's basically the essence of it. That's how aces work in blackjack. And so for 1, you would need to apply aces at the very last step. And or only the last, so the thing is, you could have a value of previous value of, let's say 11, 10. You've got an ace, so this will be 10 plus 11, and you've got equals 21. But this will make a 21 plus 1, while in fact the reality would be 10 plus 1 plus 1, because yeah, it's kind of shrinks in sizes or something. So this also needs a is last. This is getting convoluted. Is last, and we can only apply the plus 10 if it's a last card, because only on the last card it will be only on the last card it can add plus 11. Essentially, I think we will need to sort the cards to begin with. Is this our studio? No. And everyone, go subscribe to the trash channel. And yeah, we've got card value, and we're gonna create a deck. Wait. Let's create a new function, I suppose. Oops, it returns a self. And let's create a deck. Let's just say how many decks it is. Or we could could actually, yeah, I mean, we could just merge the decks, I think. Or just, well, none decks. It will be for nothing in num decks. So we will go create a for loop that goes from nothing to the number of decks we need, and it will go ahead and create our decks. So I mean, you could, the card kinda needs a suit, like what? But this is a blackjack simulator. It doesn't matter. Am I doing Advent of Code? Not actually. No. I mean, I could have done it, but now it's already December 8th. So I'm not actually doing Advent of Code, but it would have been a really cool idea. I'm just making a blackjack simulator for a video which I planned for early next year. Like probably second non-Memflow video that's gonna be released. Another one is planned for next week, but I'm not sure if I'll manage to do it by then. So what we do here is create, we've got 4 suits, right? We should probably want to add a suit value. Could catch up, perhaps. I will look into it. Maybe it's worth giving a shot. First of all, we need to push a value card that will be for in 2 through 10, including 10. It will be cards.push card number I, and we also push, let's extend, haha, it will be card Jack, Queen, King, and Ace. Will into iterate work? Probably not. And it needs to return a self, and that will be self cards. It didn't work because dot copied. Oops, it needs to derive. Clone and copy. It didn't work. Number, because oh, I need to do card, perhaps. This is really sad, I'd say. Hey, we did it. Right, and it suggests us to use iter. But essentially, what we did, we go through the number of decks we want. We go through all the 4 suits. We first add the number values from 2 to 10. And then we add the Jack, Queen, King, and Ace. And that's it. And we've got our thing. Now we need to randomize it, perhaps. Randomize. And that will be take a, I guess, a mutable self. Or maybe, oh, you couldn't hear. is also the audio volume quite well. Yeah, so what I'm making is a blackjack simulator for a blackjack strategy calculator, which I will be using for, I don't know, just figuring out how it works, how the probabilities work, and then I will use that and try to make a like a strategist thing out of it, and it will go into a video next month, which will basically be a quick summary of all that goes throughout the month, and hopefully it's gonna be really cool. Everyone loves story. Doesn't do you like stories? Tell me in the chat. We will need a random crate. Beat the casino, exactly. That's the idea. If so, chances are it won't work. But you got the idea exactly as I was intending it to be. Good job. That is the plan. So Rust updated from a survival multiplayer game to a programming language. Yes, Face Punch. They go wild. They're taking over. Soon Minecraft will be written in Rust. And basically Minecraft will be Rust. And also every other survival game is gonna be Rust, essentially. Oh, here we go. We just need a shuffle. This is super simple. Cell.cards.shuffle. Do we take any rand RNG? We could take an RNG here. Ba-da-ba-ba-ba. Shuffle. It implements RNG, and RNG is basically gonna be. Here we go. I think that will work, and we will just return self. This is, I know this is a very sensitive topic. What distro I'm running, because there are lots of people who love Arch, and I used Arch myself for roughly 5 years. But this is Fedora, and I'm loving it because I'm too lazy to set things up. And I absolutely am not ashamed of it. We need a slice random right here. Will it work? Slice random. Or will it need a prelude? Yes, it needs a prelude. Cannot borrow as mutable. Here we go. Here we go. Finally. Finally. Alright. So we've got deck randomizer. And now let's scroll a deal card. And it will take a mutable self now instead of a referenced self instead of just a self. And it will be a return a card. It would be as simple as sell.cards.pop and perhaps an option, because I'm not gonna unwrap it. Yes, everything works so far. And let's just derive a debug right here. And let's see if it works. So use deck. So equals deck new, let's take 5 decks and randomize it. If we randomize it and if we just go and take 10 cards, for instance, and we just go and deck dot deal card, let card equals unwrap, because it should always succeed. And if we print the card, we should see a result. Of course, it didn't work because we need an RNG, and use rand RNG equals, is it, we just need a thread RNG right here. Randomize using this. Here we go. And we dealt 10 cards, I think. And we got 2 aces, and if we just keep going, it seems to work. I'd say it would perhaps be wise to add a suit, even though it's kind of useless for our use case. I'd say, like, it's kind of useless, but we can attach a suit. Is it a card? And we just perhaps pub enum suit. And now I will be completely incompetent. And look up the suits, because I know you've got the hearts, and I know how all of them look like, but I don't know what they're called in English. How am I making the split full screen? It's the command key or whatever, that's Control B and press a Z, which is a zoomer effect. So, you've got, for instance, you've got diamonds, you've got clubs, you've got hearts and spades, which makes it really, really beautiful. And we just attach a suit, I suppose, to every single one of them. And we just go ahead and ignore it because it's useless. Essentially. Shifting focus. So arrow key kinda works, but I use the O key, which just goes to the other one. I used to use the arrow key, but they kinda... Let me check. Yeah, like I use the arrow key, but then it doesn't work immediately. I'm pressing the up key, so I go to the previous command, but it doesn't work. I need to like wait or something. Same thing, I need to wait. It allows to switch really quickly, but I also usually want to immediately use the command line, so I use the O key, which means other. And if you press O while holding the control key, it switches places, which is not what we want. Alright, now I think this is gonna work. We just need to import the suit. And let's just do let suit equals wait, why is this hold up, I somehow opened two things. And that's the thing, I'm still not very good at them, even though I should be, but I'm not, alas. So let's say, for instance, we take a diamond and we just take a suit, extend, so we're gonna extend it. Huh. Kind of, I'm not sure if this is the right way. Yeah, alright, well, I'm kind of feeling maybe it's better to not put the suit within the card. Maybe you could have them as tuple and just ignore it whenever you want to. I'd say that might just be better. Which is really sad. So you've got a card value. Oh. So just have it like this. And you've got a card value. And this takes a suit and card value. And that will be a suit. Well, it's gonna be a suit. Like this. Well, right now we are having a bit of a thing with... Well, you'll just see in just a second. I am just mumbling. I know that. I'm very sorry for it. I took a screenshot and that gave me a jump scare. But eventually, if you split them to new lines, the power of Rust comes in when you go to iterator copied and iterator copied and you map value to suit and value, and essentially, oops, extend it outwards. And that's it. Now we've got suit and value, and it doesn't really work really well because dealing a card actually deals a card value. Actually, no, it deals a card, but card is equals a tuple, or maybe it's a struct which takes a card value and a suit. And we derive a clone, a copy, a debug, yeet. So we take a card as well. And we also need to card value. And we just need the deck to be full of cards. And this will be a card. And this will be a card. This is a lot of stuff. A lot of difficulties. Constructor is not visible due to private fields. Yes, of course this needs to be public. So what we have here, well, right here, you've got a structure, a tuple structure, which takes just types. And it functions like a tuple, but it's also a struct, which can be a C struct. Do we take a suit or a value? Well, value first. Here we take a suit first. Well, what's simpler? That's right. Changing this. And we've got one more error. It's missing a type parameter. It's missing a type parameter. What? And this is difficult to understand. Oh. Here we go. We have a card, diamonds, but what we're gonna do now is really cool. We're gonna create a suit implementation, which is gonna have a, well, actually, for suit, we're gonna create the from implementation for suit. Std convert from, which is gonna convert suit usize to suit, and it will be fn from. Other num usize, and it's gonna return a self, and it will be a basically match num. It will be 0. Suit diamonds. And everything else is actually gonna panic. Wrong value. But this is gonna return a clubs. It's gonna return hearts. This is gonna return spades. And this is actually gonna be a reference to number. Or no. And I closed it again. How did I do that? Well, of course, having a write and quit very close to each other. And no thing inside that. Oops, we need to use this. And here we go. Now, what we need to do is just map this particular map to suit from. Do I use the error bell sound? Wait. probably too loud, I'd say. Here we go. It should be better. Slightly better, yes, I think. Sorry for that. But... oops. We just map it through this particular function. Oops. We need to take out 1, 2, 3. Here we go. Now, now we've got a generation of, as you can see, we have different cards with different suits and different values, and it's really cool. I think it's kind of useless right now, but we have basically a deck which can be dealt. And once you have the dealt deck, we would somehow want to sum it up, I think. And our summing up code is really sketchy, I think. But it will turn out really, really well. Once we actually start coding the dealer. Hold on. I think. Yeah. Let's run through quick. Cargo FMT. Deck. Alright, this is how it's supposed to look. It looks slightly better. But yeah, and now we've got the deck generation. We could actually go 52. We take one deck. And you can actually see that, well, we've got all kinds of suits, all kinds of values. And if you check, it should be just 4 10s, which is the case. And 4 3s, 1, 2, 3, 4. And is there any other one? Nope, it doesn't seem like it. So yeah, the generation works really well. Now, we just need to somehow figure out the game. So I roughly know the rules, but not exactly, so it'd probably be best to open a Blackjack rules. I know there are different rules for the dealer, so we probably want to code dealer. Dealer.rs. So dealer is going to have, well, dealer is going to have a visible card and a hidden card for starters. So first of all, we use cards. Well, card. It supposedly uses deck. And that will give us a visible would be a vector of cards. Hidden is an option of card. So when the dealer deals out the cards, he takes, well, I think he first deals a visible one, like the first one is shown. The second one is hidden, and when you stand, first of all, the hidden card is opened, and then it deals until the total sum becomes, well, between 17 and 21. Well, from 17 upwards. And there is this thing of whether the dealer stays or hits on the 17. But I'm not sure, is it whether the dealer stays on hits on 17 or whether it's when dealer stays on hits on ace plus 6, and I'm not sure. But something will happen today. So implement dealer. Well, we have a default implementation which will have nothing. And we will have so we will have a function initial hand, and it will take a deck. We'll have initial hand, and then it will be a final when it stays finalize. So initial hand, I would open up GTA 5 if I was not running on Linux. Well, it doesn't really matter, I think. Well, actually it does. Well, not quite. The decks are shuffled. It doesn't matter. Let's say we first add a hidden card. So we take a deck. We'd also need players later on. So it will be self.hidden equals deck dot deal card. This is so beautiful, we don't need to unwrap anything. Self.visible. First of all, well, self.hidden.take, self.visible.clear. Just clear it out for good measure in case we mess it up. But visible dot push dot extend deck dot deal card, and that's it. That's how the initial hand goes. We will also need to go through the players, I think, but finalize will be self.visible.extend self.hidden.take. What we do here, we essentially take the hidden value. If it's something, it's gonna make it none. It's gonna make it none and push it to the visible. If there's nothing here, which usually shouldn't happen, it is going to just add nothing to the visible hand, to the visible state, and yeah, it will work, I think. And we also need a deck. And we need to sort it out, I think. Pretty sure. So now we need to create a loop while value is less than 17, essentially. Do something which is self.visible. Well, let's push it actually. Deck deal card dot unwrap. In case we enter an infinite loop, we don't want to enter an infinite loop. And that will be this. but now we need to calculate the value, which would ideally be something very ergonomic. I wonder how to best do it. So I think the best way would be, well, card sum of self.visible is less than 17. What we're gonna do here is add a sum of function to the card class, well, structure, card implementation, which will take sum of cards, a slice of card value. Actually, no. Implementation of iterator. Here we go. And it's going to return a usize. And we're gonna have a let mutable ace equals none, and we go for card in cards, or card in cards. If let none and card value ace equals ace and card, basically, if we have nothing in the ace, which is here, and we have an ace as our card, we have ace equals some card value, some card essentially. Else let my total equals 0. Total plus equals card dot value, and that will be total false. And at the last step, if let sum ace equals ace, total plus equals ace dot value total true, and we just return a total. I think that might just work. Sum of the harder part is here. It will be a self.visible.iterator map card value I think that might work. Here we go, it compiled. But we don't use the dealer, so use dealer looks like a drug dealer, but it's not, I promise. And we will actually use card. Actually, no. We take this, which is all fine. But we just implement the same thing. For card. Implement card. And it will be sum of cards, and it will be card it will be card value sum of cards iter map and it will be a mapping value. There we go. That should work. No, it didn't. Because we might just want to use this. No deck in card. Yes, because it's actually in there we go. We've got that done. Huh. And essentially right now we're gonna have a final sum. Let final sum equals sum of visible, and we will be, did the dealer bust or did the dealer win? I think, well, he's playing against himself, so, or themselves, but it's gonna be a really fabulous, I think. If final sum is more than 21, else in here we have dealer busts final sum, and it still compiles. And what we're gonna do is we're gonna create a dealer. Let mutable dealer equals dealer default. Yes, here we go. And now we're actually just gonna we need to add a check for decks. We're gonna add a check for decks. We're gonna do this right here, which will be finalized. And this right here is gonna take, okay, sum. Final sum is less than 21. More than 21. Oh, less or equals 21. And what we have here, while we're gonna loop gonna go dealer dot initial hand. Beautiful deck. Okay, we take a deck, and we're gonna do a dealer dot finalize. And basically, if dot is none, break out. We have a lot of dealer busting. Jesus. But as you can see, it kind of is randomized. But essentially, dealer busts quite a lot. How the hell did it get to 30? It needed to have. Alright. That doesn't look good. Dealer busts 42. That's wrong. That is wrong. That is absolutely wrong. Because you can't have it like that. So, let's see. Card. Let card equals. And card. Card. Here we go. How the hell does it get to that point? So we have a hidden, self.hidden, yes, invisible, self dot visible index out of range, but with iter dot next. Alright, so what do we have? We take a 5, we take a 7, and we have dealer did not bust at value 19, which is not the case. Oh. Alright, because for some reason we decide to add it in, but we don't need to add it in. Fair enough. Fair enough. Mm-hmm. Don't need to add it in. And now we finally have it sort of working, I think. Now let's just remove the prints. Yep. Eat. And yeah. No, we still have it. Why? Oh, because we add here as well. And now we actually have a proper blackjack thing working. Hey, dealer busts, dealer did not bust. Yay, it's sort of working, I'd say. The chances look alright in my opinion. Hold on. But yeah. That works, in my opinion. Now we just need to add players as well. As players, well, they're needed for blackjack, aren't they? So essentially we have dealer, which right now we would actually want to do a put that hand, play hand, and takes a deck, and it's gonna return a option of whether the dealer busts or whether the dealer didn't bust, and we'll change it to a status of what happened, and it's just gonna be self.initialHand and self.finalize. Simple as that. And we replace that while dealer.playHand take a deck dot is sum. Well, this gets simplified a lot. Oops, they need a deck here. They need a deck here. And now, here we go. Now the main function is awfully lot simpler. As you can see. But we've got the dealer going. What we will need to add now are players. Players will essentially, right here in the initial hand, between here, the players will be given a chance. Let players play. And then they have the bust, they don't, whatever, and then you have a comparison. So because we're gonna make a simulator, we'll probably want to have some kind of trait for player. A trait for player, and we're also gonna have a basic standard input player, which will have basically the cards and stuff given to. So we're gonna have a pub trait player. So the standard input player will allow us to pick whether we hit, stay, whatever, etc., etc. And when we optimize the strategies, we're gonna allow the players to be AI, well, scripted at least, coded players. So we will create a trait for players, and that will be fn play step. And it's gonna receive it's gonna have a mutable self. It's gonna receive a deck. It's gonna receive a deck. Well, deck is kinda, well, let's say it receives a deck. We're gonna have access to dealer. And we're also gonna have access to the rest of the players. Other players. Mid. I don't think we can do that in traits though. We can't use implement trait on non-trait. Or maybe we can. We can't return it. Let's see. This is a long boy thing. Yeah. We first need to import use crate card deck use crate dealer, and that's it, I think. Yeah. Oh, it actually works. Right. So we have a play step where we have basically the whole context of the game. We might want to move deck into the dealer so it's simpler, but whatever, for now it's separate. And we will have a stdio player, and it's gonna hold cards back card use crate card it's gonna hold cards, and the implementation is gonna be we're gonna implement player for stdio player, and it's gonna be a play step. The play step is gonna be essentially print out all the cards we've got. So it's gonna be for card in self.card. It's gonna be cards. We're just gonna print out debug print. I don't really care. The card. You're gonna total value is going to be card sum of cards self.cards, and once you have that, it's actually not gonna do anything. We're just gonna go to the dealer, play hand. We're gonna add players. Gonna use create player. We're gonna let players play, essentially. And how we should actually function it out. Maybe ask give card. It's gonna take do action, and it's gonna return the action, which in our case is currently gonna be a hit or stay. And this will be then deal card. So we don't need deck. We only need, we have dealer cards. We take cards, essentially, a list of cards. So we have the information of dealer cards, other players, which will have a get cards function, then get cards self, and it's gonna return a card list, essentially. And deal card is gonna be called by the dealer. It's gonna just add a card. Simple as that. And this feels like the trait I would use. So we're gonna have a do action which does it like this. Total value will be your cards. It will be the get cards is going to return a sell the cards, and deal card is gonna just do a self dot cards dot push card. I know we will need to have a separate decks for when you like split and stuff, but for now let's keep it simple. So we have get cards. So you have our cards. We have we're gonna loop through the player cards. Actually, we put our cards at the very bottom. So we loop through every player and other players dot iter dot enumerate. We do the same exact thing actually. Player this cards through p dot get cards. Get cards, and that should work, I think, hopefully, perhaps not, but we will see. And we go your cards, but first we actually need to go through dealer cards for in dealer cards. It will be print. We messed something up. I can feel it. Dealer cards will be, oops, and we have total value we don't use here. We messed something up really badly. We didn't close something. We have this, we have this, we have this. Do action, yes, we are missing this particular delimiter. And we're gonna return just false. Let's stay. And deal card, yes. Ah, it worked. Now, what we're gonna do is essentially do standard input, and I always forget how to do it. Rust, read, input, line. And that will be a really old Stack Overflow post. Well, let's just for now return false, essentially. And right here, for P in players, we somehow actually need right here, other players. Huh. It will be an implement iterator. Item equals implement player. Here we go. I think that should work. Perhaps. Maybe not. And it will actually take a reference. Not the whole player. Players, do you enumerate? And what we will do, this is ugly actually, p dot do action, let hit equals p dot do action, and we take dealer hands, which will be cell.visible. We take other players, which will be players.iterator.enumerate dot filter. Filter out whether I not equals p map. This is ugly, but p. But it is what it is. It is what it is. So we do the action, and if hit, we do this will probably not work, but deal card. Yeah, this will probably not work. Deal card. Huh. Deck the deal card. It'll absolutely not work because we messed up the syntax. But consider adding a lifetime bound. Whatever, let's not do this. Play hand expected 2 arguments, yes. Oops. I not equals O. Now. Hold on. Instead of iterating through these, we just do it. Now, we have 2 issues. We need that and we need that. So, first of all, implement t deref mid target equals implement player. Can we do that? Well, probably doesn't matter for T. Solve the dref dot get cards. Do action, dealer cards, other players. Will this work? Probably not. We need use std ops dref we need this and missing trait in a trait implement. Oh, actually need to, you know, to specify which trait we are implementing. All right, let's see. All right, this stuff. Scratch that. Scratch that. Or maybe not. So I'm confused. Maybe not. Maybe we just take, instead of iterator, maybe we just return other players, implement player, and we skip local ID, use size. Maybe this will work. Other players dot iter dot enumerate dot filter will be local ID. Maybe this will work. Okay, this is a lot. Do action players, and we take pass I. And we just do play hand of empty thing. Cannot infer type parameter because obviously alright, let mid players equals vec of nothing, and it will be a box of din player. Use player Oops, 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 oops. This is a vec of that. Now, just need to implement the trait. Because yes, it has generic type parameters. Other players. Alright, well now we don't actually use the implement player. We're actually gonna use a slice of box teen player. Hey, this gets simplified a lot. And now, of course, we cannot borrow it as immutable because it was already borrowed. Come on. All I need is the cards to every single player, which is tough. Or we could just copy them out, I suppose. Let's go player cards. It will be a it doesn't really matter, right? So it will be just a list of cards. It doesn't matter if it's 2 or 5 players because we're not playing against them. So it will be player cards, it will be a list of cards. And it will be simple as that. Player cards. Ba-da-ba-ba-ba. And in actually we are not gonna print out the values because it will be incorrect. This is tough, I'd say, isn't it? Dealer, we just pass an empty thing. Ba-da-ba-ba. Hey, we compiled eventually after, I don't know, 20 minutes, we did it. Alright. Let's see. What do we have now? We have that, we have this, and that. We're gonna use a player. CDIO player. And we're gonna do players.push. CDIO player. It will be derive default. But into, will this work? No. Box new. Alright. So your cards, total value 0. dealer cards. We print the dealer cards, and we have the thing. Right. Ba-da-ba-ba-bum. And hit or stay. Yes or no? Let match std io lines dot next dot trim h s hit hit. It will be let's see. It didn't work. Yes. Let's see, will this work? No. Method not found in std_in. Huh. Let's check out my code. Memflow applied, because I'm sure it has the code. I always forget it. Get line. Alright. So let line equals string new, and it will just be alright. Dot okay. Line dot trim. Not found in this scope. Let's see if it works. Yes. Hit or stay. Hit. Yes. I've got total value of 5. Hit. Hit. Jesus. What kind of cards are these? Hit. No. Well, I need to... Doesn't matter. Essentially, now what I need to do is in the dealer, I'll create a vector for whether we hit or not. So let mode hits equals vec true players.length, and it will be to enumerate first of all iterator mod dot zip hits dot iter mut. Yes, so we have a player, and hit, so it will be hit enumerate dot filter. It will be something hit. And this absolutely didn't work. Alright, so we press N. We have dealer busts. Hit, we're asked if we want to hit. Press N. We pressed N and we got the thing. We need a reset function. Fn reset cards. We should also probably make sure the cards are managed outside, because this is a little bit, let's just say, the responsibility is not for the player to manage the cards. Let's just say that. Let mid had hit equals true while had hit. And had hit equals true. I think so. This should be it. Yeah. And yeah, we just go right here. Players intermit. Actually, no. Let's go to the dealer. For P in players dot intermit do P dot reset cards. And that should be it. Yes. Hit. How the, oh, we had an ace. Hit. 26. We should have busted, but doesn't matter. No. Dealer did not bust. We reset the cards and we have it. We currently have it right here. We have a really, really rough simulator. We should actually check if bust. Oh, we should actually just change this to whatever. If card sum of p.get cards is higher than 21, print line player bust. Ta-ta. Player bust. Player number bust, and it will be just I. And it will be hit equals false. This is very ugly at this very moment. But you have that, and you have finalize, and then the main function. We're actually just gonna go through. No. Well, this is what we're gonna have. We have quite a lot of things. So we have go to 26. How the hell did it get to 26? Oh, we had player bust. Yes, we had player bust. And then it asks us again. Player bust. Wait, this doesn't make sense. Why did it ask? It keeps asking and it keeps going. We print that the player bust and the player did bust, and it keeps going. It should actually not find anything. not find any player, you know. So we enumerate everything and then we filter. Let's see. Let's see. It shouldn't be like this. Oh, yes, of course. Yes. Now, we got a 10. We had. Now, this is a good card. I'm just gonna play it. And Pleader did not bust and he got a 17 and we won that round. Here we go, we won that. But, essentially, hey, player bust and it skips it and it works really, really well. Alright, so, yes, I mean, we did this roughly kind of working blackjack simulator. It still has lots of rough edges. And what we have a really simple main function which just creates, or RNG creates a deck, creates a dealer, creates players, actually one player which is standard input player, and just plays hands until there are cards. And we have this really easily, and that is just play hand, which goes through essentially while any of the players did hit, it goes through all the players that did hit in previous round, or it's the first one. We just assume that they did hit and asks them to do an action, and the action is whether they hit or not. And if they hit, we deal them a card. If they didn't, they get filtered out for the next, and then the dealer finalizes, which basically goes until it's like 17 or more. And then we calculate whether the dealer bust or whether the dealer did not bust. We didn't calculate who won yet. We didn't calculate that, but I'd say, I mean, this is good enough for now. And we had players, we have cards, which are really nicely abstracted away. Like, look at this deck code, it's so beautiful. We just input the number of decks we want, and it goes through the decks, and it creates a deck with all the suits, with all the numbers, with all the jack, queen, kings, aces, and it just works. This is the magic of Rust, I'd say. This code is a bit more ugly, I'd say, but it will do for now. In the next episode, we will continue this and probably start coding a strategy and stuff and betting and stuff. That might work. Hopefully, I'm not sure, but yeah. Thank you very much for watching this. Watching the stream. I saw quite a few people coming in, and it was very lovely to see you all. 3 people still watching. Hello. It's very good to see you, and yeah, I guess we'll see next time when I stream. I'm not sure when, but sometime. So yeah, thank you very much for watching. Don't forget to hit that like button, overflow it, hit subscribe for more videos like this. I mean, this is a stream for more streams like this. And yeah, thank you for watching. My name was Heap. Yours wasn't defined. See ya.